welcome. Here we are, another day. Let's take a few seconds here before we begin. Make sure the audio is working and the live stream is working and the chat's working, all those things. Make sure the audio is working and chat's, and I have the chat out already. All right, so this question is going to be count number of nice subarrays on LeetCode, and we'll go ahead and try to get this going. See how we do. Try to go quickly. Given an array of integers nums and an integer k, count a continuous subarray is called nice if there are k odd numbers on it. Turn the number of nice subarrays. Interesting. Exactly k. Okay. Only subarrays with 3 odd numbers are 1, 1, 2, 1. 1, 2, 1, and 1, 2, 1, 1. Okay. Yes, there's a way to do this. It's not too. I think you can do this in linear time. What you're going to want to do is do a single pass. So int result current amount. I'm going to say const int x and nums amount plus equals. So no. Left, right, sliding window. I'm sure sliding window. Increment L, I'm gonna do 4. I like to do a loop first, so the left side. Yeah, actually it's fine. It's fine. You can do it this way. So for r is less than n and amount is less than k. I'm gonna increment r and we're gonna increment amount plus equals nums of r and 1. So if it's odd, increment. So and so we start L and we move left to right with R, incrementing, and we're going to say result plus equals amount equals k. Okay. So we add the value and it's going to be result is times L minus R. No. Oh. No, not sliding window. Okay, I got that wrong. This may not be as easy as I think. Okay, hold on. So, back to the question. I think I might be wrong at that. Because it could be... No. Yeah, no. Sliding window I don't think works quite as well as I'd like it to. As I can go each left point and I can move to the right and find out how far to the right do I need to go to get. Well, the thing is, it's an increasing number. The number of odd numbers in the in that particular subarray, and there's actually a range for a particular left value. There are 2 points, 2 right values that I could look for, because that the number of odd numbers in that subsequence as R changes from left to right, that's an increasing sequence. That's a sorted range. So I could binary search. I think I could do this in linear arithmetic time, But I think I could do it faster if I, well, yeah, maybe a binary search is the way to go, actually. Yeah. Hmm. I'm almost certain I could do this in n log n time, right? Take at each point left side, a binary search to find at what point, where's the lower bound where the amount that I'm looking for is equal to k, and then where's the upper bound where it's no longer equal to k, right, where it's larger than k. And that difference between those indices is going to be, all those are going to be subarrays that I want. I'm just trying to think if there's a way to do this in linear time. That's a reasonable way to do it in linear rhythmic time. That should be fast enough. Also, a relatively small number of, pretty high acceptance rate and high number of submissions. Yeah, it's like not such a hard question. Probably you could do a sliding window though, right? Could I do a sliding window? I don't think I could do a sliding window, the more I think about it, because I would need to back up my right value a little bit. When I increment my left value, I have to back up my right value. Actually, I could maybe use a stack. Oh, that might be a good way of doing it. Yeah, that's an interesting idea. So as I move from left to right, I add, some odd numbers or remove odd numbers. This is similar to, this is like if I had zeros and ones, the number of subarrays that are, the number of subarrays that sum to a certain value k. It's like another way of looking at this question. Huh. I'm sure there's a way to do this in linear time. I'm thinking there's a way to do this in linear time. I think this is similar to another question I've already solved, by the way. Think about this. Excuse me. I think you can do it in linear time. I think you can do this in linear time because just thinking back to what I was saying before about, like, this is an increasing sequence, right? The number of odd numbers. And from left to right, maybe I should have 3 variables: left, right 1, right 2. And right 1 is where it begins, and right 2 is where it ends. And I can find that in, less than linear time, right? Roughly linear time. And then now I have the next element for L. I either remove an odd number or I don't. If I don't remove an odd number, the two right values don't change, and I just reuse exactly the same calculation I just had. If it is an odd number, then I've got to move my left value, my left R1 over, and I've got to move my right R1 over until I get another odd number for both. And all three of these variables are never going to go backwards. Yeah, you can do this in linear time. Yeah, that works. That's a good way of doing it. I like that. I like that. I like that. It's a little bit not what I'm used to, but it works. So R1 and R2. And we're going to say, so R1, and I'm going to say amount 1 and amount 2. So these are going to be associated with R1 and R2. And the way this is going to work is I'm going to set R2 equal to R1. And I'm going to say, actually no, that shouldn't happen that way. Both of these should just be R2. Just initialize the same way. Okay, so amount 1 is less than K, amount 2 is less than or equal to K, right? So this is going to be the upper bound, this is going to be the lower bound, right? And then this is going to be amount 1, amount 2. Come back to the result. R1, R2. Okay. All right. So now my result is going to be the sum of, it's going to be R2 minus R1, and it's going to be the way this is going to work is R2 minus R1, if they're on top of each other, that means it's empty, right? Yeah. R2 should always be to the right of R1, and R2 doesn't include the amount 2 is not equal to K, so it should be subtract 1 from R2. Okay. Then what's going to happen is if L is less than N, so this is got to be careful here, L is less than N, then what I can do is take amount 1 and subtract nums of L and 1. So if nums of L is an odd number, I'm going to subtract from amount 1 and from amount 2, I think. Both of these are going to lose that amount. And then I'm going to update L to the next spot, and then update R1 and R2 appropriately. It's something along these lines. I don't know if this is correct. I could try this. This is an interesting way of doing it. R1, and I think also R2. R2 actually doesn't have to be less than N. Yeah, R2 is fine. Not an issue. Should not be an issue, I think. Something along these lines, I think. So I got output 1, expected 2. Okay, so 1, 1, 1, 2, 1, 1. What happens with this in this case? It worked in this case, but what about this one? So we start off here and we say, all right, R1 and R2, we're going to move R1 over to 1, 2, 3. So it stops here. Amount 1 is now 3. And then R2 goes further than 3, goes all the way here. 1, 2, 3 goes to 4. Okay. Or amount 2 goes to 4. So 3 and 4. Now my result is going to be the difference between these two. Is that correct? That should give me 1, right? That gives me 1. 0, 1, 2, 3, 3, and 4 gives me 1. And then the next iteration, L is less than N, it's 0, we go to 1. Decrement 3 and 4, right? Now we move this side here, R1 again. Okay, so mount 1 should be now, so it was 1, 2, 3, now it'll go, it's 2. Should be 2, the other one is 3, so this, we have to do one more. Add, so 0, 1, 2, 3. So what's interesting about this, I think this R1, it actually is where is R1 actually? Not so obvious to me exactly where that is. I think I know where that is, but I don't think it's totally correct. I don't think it's where I was expecting it to be. Yeah, it's a tricky thing here. 4, 4, and 5, 5. Yeah. 0, 1, 2, 3, 4. So I was expecting it to be at 3. Yeah. So this is kind of interesting. The issue here is this is actually 1 to the right. So odd, odd, even, odd. 1, 2, 3. K actually ends up at 4. Or R1 ends up at 4, not at 3. It ends up 1 to the right. And here being equal to K, we'll add 1, 2, 3. And then this is also going to be 1, 2, 3. R2 is 3. Excuse me, R2 is 2. We enter here, and R2 ends up here when amount is 2 is equal to K. That's kind of confusing. It's really confusing. But yeah, it ends up a little bit to the right, actually. And then I think the tricky thing is I think they're 1 element to the right, which is confusing. As long as K is not 0, right? K is never 0. I think I could just decrement both of these, R1 and R2. Like I think I want the last element before that happens. Which, yeah, that's like an off by 1 error that's kind of confusing and not so obvious to address. Okay. Now I got 4. I think it's not what I want. Yeah, that is confusing. Also, that should be R1, R2. Yeah. Okay. That's not supposed to happen so many times. Yeah, that is confusing. Oh boy. Maybe this is what I want. It's tricky, very tricky. Off by 1 related issues. Actually, this should be +1 and 1. Could do a pre-processing step to just make all of the numbers 0s or 1s also. Make things a little bit easier. Okay. Now it's fine. Of course. Of course it is. Yeah, that's tricky. That's very tricky. Yes. So let's actually I could transform this. I think that works. I think that's correct. By the way, I think this is the right answer. So can all the numbers? There was at least one, right? Oh, okay. We'll just do 1 2 1 2 2 2 2 1 1 1 1 2 2 1. Just some random stuff. Okay, let's try this again. I think I got it. Let's do 1 and 2. 1. Oh. Okay, I'm gonna go for it. Could be wrong. Oh, got it. Nice, very good. 1 2 3 4 5 6 6. This is linear time. I mean, this is one reasonable way of doing it. We could also do standard transform. And it's going to be the following. And this is going to be, I don't know if that's the right syntax. I have to double check that. But yeah, I mean, no. I think that might be it. If I remember exactly how it works. Yeah, so now I can actually, I don't need the and one anymore. Remove a few operations here. Which I don't know if it really matters, quite frankly, but maybe it does. Maybe it does, I don't know. Okay, try again. Try again. Okay. May or may not be faster, I don't know. Oh, okay. Looks reasonable. 1 1000, 2 1000, 3 1000. Not the fastest, which is kind of surprising. I mean, it's linear time, it's pretty fast. A couple more submissions, I think. That didn't take too long. That was reasonable. 20 minutes. 1 2 3 4 5. That was a tricky one, though. That was definitely a tricky one. Getting this part right is not obvious at all. Yeah. I've like kind of struggled with loops of this nature in the past, where it's just something about it is weird. Something about it is weird. Also, I think these could be these all could be iterators, I think. Could be faster by use iterators. Let's try that. Let's try it. Just another way of speeding things up a bit. I think I could do it this way. It's a little more confusing if I do it this way, but I think I could do it this way. Let's see if I can. Okay. Gotta go for it. See if that works. Yeah, and it's a little bit faster. A few milliseconds shaved off. 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, 6. Yeah, that's a little bit faster. A little bit. 1 1000, 2 1000, 3 1000, 4 1000. Trying to think of another way to, like, how could it make this faster? I mean, this is reasonable. It's I'm a little disappointed it's not the fastest. That's what I'm kind of disappointed. Feels like it should be faster. Yeah, okay, there we go. 98.87%. It's pretty good. That's reasonable. Not 100%, but close. You know, I think if I kept rolling, I might get 100%. There might be like some other slight things I could do differently here to make it fastest. This is kind of awkward. This might be part of it. This could be part of it. But optimize the code a little bit more. I'm sure there's stuff that could be done. We'll just leave it as it is. But yeah, that's a basic idea. It's pretty good. That's a reasonable approach. Instead of trying to use linear rhythmic approach, you could do. And this question is kind of generalizes to other stuff. Like there are other things that are very similar. It's basically counting, like count the number of, if you had an array of zeros and ones, count the number of subarrays that sum to a certain number, right? You could do that in linear time using this approach. And then in the different variations where it's like you have some property of the number that converts to true or false, then you can apply the same algorithm and get a relatively fast solution every time. So yeah, thank you for watching. I'm gonna restart the stream on a new question. If you like this video, give it a like and subscribe.